Alright, for part B, it says write but do not evaluate an integral expression that gives the total distance traveled. Total distance, whoops. Total distance traveled by the particle from time t equals 0 to time t equals 6. So I'm thinking total distance. What is that? Total. I gotta turn on the music. So, well, I have the velocity function, and I know that integrals kind of undo velocity. So the total distance traveled could be represented by the integral. Yeah. If I have the rate, remember we talked about a rate function. If I have a rate of like time and position, then the area underneath is the distance traveled. So, and that's represented by the integral. So for part B, the integral would be from 0 to 6, and it would be of cosine of the velocity, right? Pi over 6 times t dt. It says, write but do not evaluate the integral expression that gives the total distance traveled. There we go. Actually, this is not completely right yet. If I had velocity dipping back and like being negative, which I do, I definitely do have that, this would actually get me the net distance. Remember, the integral is the net area under the curve. So it's not. This is actually not the total distance, it's the net distance traveled. To get the total distance traveled, I just take the integral. Oh, this is a way easier way of doing it. When this is positive. So I can cross this out, and I want this area, and this area. Well, the way I do that is by taking the absolute value. That's a way easier way than the way we were doing it before. So that's pretty cool. So that's the total distance traveled. You can use the integral with the absolute value function. We don't have to evaluate it, so we can just put it there. We could split it up into pieces and evaluate it, but we don't need to. So that's for part B. Maybe I'll do part C in this as well. Find the acceleration of the particle at time t. Find the acceleration of the particle at time t. Okay, immediately, it's not saying a specific t value. It's just saying at any time t. I know that if I take the derivative of this, I get acceleration. So a of t equals v prime of t. Okay, so I'll just take the derivative of cosine pi over 6t. That's using chain rule. So that means the derivative of cosine is negative sine, so that's the derivative of the outside with the inside the same. So I write pi over 6 times t times the derivative of the inside times pi over 6. And I don't need to make it like fancier or look prettier or whatever. That's it. So that's part of it. Is the speed of the particle, is the speed of the particle increasing, decreasing, or neither at time t equals 4? Explain your reasoning. Remember, speed, when it's talking about speed, we had a little chart. If the particle is, let's just say, acceleration, velocity, and speeding up or slowing down. Speeding, is that what it's asking for? Particle speed increasing or decreasing? Yeah, speeding up or slowing down. We had a chart, so if we had acceleration was positive and velocity was positive, then we're speeding up. If acceleration was positive and velocity was negative, we'd be slowing down. That means in any combination of this. So this would be slowing down. If we had negative, positive, that's slowing down. If we had negative, the particle was going backwards, but also has negative acceleration. It would be speeding up. That's weird. So that's what I'm going to be looking for. Just find out the sign of acceleration and the sign of velocity, and we're just going to explain our reasoning just like we just did. So it's saying at t equals 4. So v of 4, that would be cosine of pi over 6 times 4. I would reduce that, divide by 2, that would be 2 and 3. So I really have beautiful bell we have. That cosine of 2 pi over 3. So where is that? On the unit circle. So I have the pi over 3s. That's 1 pi over 3 is that slice. 2 pi over 3. This is a pi over 3. Cosine is negative. So this is negative. And then the acceleration at 4 would be, well, I decided the acceleration function. That would be negative pi over 6 sine of pi over 6t. Yes. Over 6 times 4 in this case. So again, I would reduce. That becomes 2 and 3. The sine of pi, or 2 pi over 3, that's positive. And then times a negative, that's negative. So my particle is speeding up, right? Because that falls into this area. So my particle is speeding up because the particle is going backwards, but also accelerating negatively. So that means it's getting faster and faster by going backwards. So I would write that in a sentence. The particle is speeding up because it is moving to the left and accelerating negatively. And that's your reasoning. There you go. I'm done with part B and C.